The 3-4-5 method is one of the oldest tricks in the builder's toolkit. Measure 3 units along one side, 4 units along the adjacent wall, and if the diagonal measures exactly 5 units, you have a 90-degree corner. It is fast, requires no calculation, and relies on nothing more than a standard tape measure. But on a modern construction site, relying strictly on that small 3-4-5 triangle introduces a specific vulnerability: the small triangle, big error problem. This diagram shows a 20-meter foundation layout. If you only run a 3-meter by 4-meter triangle at one corner, you are working with a tiny fraction of your actual structure. A minor 2-millimeter marking smudge at the corner amplifies as you project that line outward. By the time you reach the far edge of the layout, that tiny error has widened to 40 millimeters. By using the True Hypotenuse Method, you work strictly with your actual site dimensions. This eliminates interpolation, ensures millimeter precision across the entire span, and prevents those small marking discrepancies from compounding into structural problems later. This mathematical formula calculates the exact diagonal required for any 2 measured wall lengths. You take the length of leg A, square it, add it to the squared length of leg B, and calculate the square root of that total to find your precise target diagonal, which is C. Step 1 is to establish your corner. Set a clear, fixed reference point, like a nail or a peg. Every measurement will pull from this single, stable location. Step 2 and 3. Measure along your first wall line to your actual planned length to get leg A. From that exact same corner peg, measure your adjacent wall to its full planned length to get leg B. Step 4 happens before you even pick up the tape measure. Pull out your phone calculator, enter your measured lengths for A and B into the formula, and generate your exact target diagonal. Finally, step 5 and 6. Pull your tape measure between the 2 endpoints of your legs. If the measurement doesn't match your target number, shift the free wall in or out until it hits your calculated diagonal exactly. Taking 10 seconds to type the actual wall lengths into your phone replaces trial and error with a mathematically perfect layout. Let's apply this to an internal residential renovation, specifically a room measuring 3.65 meters by 4.85 meters. This top-down layout shows the exact math required. You square 3.65, add it to the square of 4.85, and take the square root. Your exact target diagonal for this specific room is 6.070 meters. If this layout is off by even 5 millimeters, the error becomes visible during the finishing stages. Floor tiles will fan out, and skirting boards will leave noticeable gaps against the wall. We apply the exact same logic to the most critical check on a residential site, setting up a standard 15-meter by 20-meter house slab. Looking at this slab layout, we run 15 meters along the width and 20 meters along the length. Squaring and adding those numbers gives us a target diagonal of exactly 25.000 meters across the batter boards. A concrete slab poured just 20 millimeters out of square cannot be easily adjusted. Once the prefabricated roof trusses and brick veneer arrive, correcting that concrete error will cost thousands of dollars in remedial work. You also use this method during site establishment, before any concrete is poured. Consider a large building lot peg-out measuring 28.5 meters by 42.75 meters. This site diagram shows the calculation scaled up. Using the exact lot boundary dimensions, the formula gives us a precise target diagonal of 51.379 meters between the corner pegs. At this scale, tape sag and wind create physical challenges for the measurement. You need to support the string line over long runs to ensure your tape is pulled tight and reading true. We can also use this for attached outdoor structures, like a timber deck extension measuring 5.5 meters by 7.8 meters. This deck framing plan requires squaring the bearers to the house. Running 5.5 meters out and 7.8 meters along the wall gives us a calculated target diagonal of 9.544 meters. When attaching a structure to a house, never trust the existing cladding to serve as a perfectly straight reference line. Always pull your measurements from a fixed structural anchor, like a column base or post. Finally, we apply this to heavy formwork, such as a double garage setup measuring 10.2 meters by 14.8 meters. The formula dictates a target diagonal of 17.974 meters. With formwork, you must measure your diagonal, install your bracing, and then check the diagonal a second time. Hammering pegs and site vibrations can easily shift the boards out of square after your initial measurement. Whether you are pegging a lot to comply with council setbacks or setting formwork to ensure roller doors hang correctly, Using the full dimensions of your actual structure guarantees the necessary accuracy. This is the parallelogram trap. A corner appears perfectly square, but the walls are actually skewed, leaving you with unequal diagonals. To prevent this, apply the golden rule. A true rectangle has two completely equal diagonals. Both must match your calculated target. The traditional 3-4-5 ratio works well for a rough initial layout or a quick corner check. But before any permanent materials are fixed in place, verifying the entire shape with the True Hypotenuse Method is mandatory. It takes 10 seconds to calculate the exact diagonal for your specific site footprint. Those 10 seconds serve as the cheapest insurance policy against the most expensive layout mistakes in the industry.